Hey guys, welcome back. Today we're looking at 3.2 set and interval notation. So this first problem they're giving us in set notation, the set we know is the same as when we looked at sets from functions. It's indicated by the braces. Now, when we read this, we read it like this. So x, this line says such that, and then we see -6 is less than x, and then is less than, than or equal to -4. Okay, so this line here says such that, and the rest is pretty straightforward. Okay, so if we're asked to graph this, we're going to find -6 and -4 on our number line. So -1, -2, -3, -4, -5, -6. Now here's the thing to remember. If it does not include the point, so if if -6 is less than x, right, that doesn't include -6. So another way to think about it is x is greater than -6. So it doesn't include that point. We're going to put a circle there. We're going to leave it open because it does not include -6. However, on the other side, we have x is less than or equal to -4. So -4, because it says or equal to, then we include this point. We shade our point in. And then looking here, it's saying that x is in between these 2 points. So we're going to shade everything in between our 2 points. It's something that you guys covered in Algebra 1. I'm thinking that you should have. I'm not sure if you did or not, but if not, then real quick, it's not too bad. But if you did, then it's just a little refresher. Okay, so interval notation might be new to you. Interval notation uses parentheses and brackets. Now, the parentheses are used for less than or greater than if it doesn't include the point, and this one is for or equal to, but because it does include the point. So let's look at this. So we're gonna just write the last and first numbers here. So it goes from -6 to -4. Notice that the left hand side, it's less than. So we're going to use parentheses on this side. And then on the right hand side, it's or equal to, less than or equal to. So we're going to use the braces because it includes the point -4. It does not include the point -6. Okay, so it can be confusing at times. It does look kind of like a point, especially if you have just 2 parentheses. But the more you work at it, the easier it gets. Like, this is more, the set notation is more to remember and more symbols. The interval notation, I think, as you guys get further in math, pre-calculus and calculus, a lot of times the easier way to do it is in interval notation, and you'll see interval notation probably more than you see set notation. Okay, some more stuff, some word problems because we need our practice. It says the cargo of a truck weighs no more than, so that's important, no more than 2,000 pounds. So let's say that W is the weight. And let's write an inequality here. So the reason why no more than is difficult is because more than you think is greater, but if you think about the weight of a truck, it can only hold so much, right? So no more than actually means less than. And then we always have to ask ourselves when we're doing inequalities, can it be equal to? So no more than 2,000 pounds means that it could be still 2,000 pounds and be true. So we're going to say W is less than or equal to 2,000 pounds. So we kind of set up our set notation, right? We're going to put our braces. Our variable is W, so we're going to say W such that W is less than or equal to 2,000 pounds. All right, in interval notation, we're just gonna say that it goes from the least amount, right? So it could be 0 pounds. And notice we put the bracket because it includes 0 pounds. Your truck could definitely have nothing in it, right? And then the maximum would be 2,000 pounds. And again, we're gonna put braces or brackets because we could have exactly 2,000 pounds and still be okay. All right, the next one says the car's fuel efficiency is at least 45 miles per gallon. At least is another tricky one because you think it's less than or equal to, but at least means that you could have that much or more, right? So let's say that the car is going to be greater than or equal to 45. Right, we're just setting up an inequality so it's easier to write our set in interval. So set notation, we're going to say C such that C is greater than or equal to 45. Now in interval notation, the least we could have is 45, right? And it's included in that, right? It could be 45. That would satisfy the statement. And then it doesn't say the max amount, right? So even though you could go infinitely many miles per gallon, which is probably not happening, right? Unless you found some way to be super fuel efficient that we don't even need fuel. We're gonna say it goes to infinity because we're unsure of the maximum that we could go. And then anytime we do infinity or negative infinity, we can't actually reach that, so we're gonna put parentheses here. So we're gonna note for parentheses on negative infinity or infinity. Okay, the last part is just some work from like Algebra 1 type things, just reviewing some stuff about inequalities. So if we look at this, one thing to note is that we have an open circle, which means that we're going to have less than or greater than. Also note that the shading is to the greater than side. So we're going to say that whatever our variable is, let's say x, is greater than -5, right? It doesn't include, so we're not going to say or equal to. Okay, the reverse of that, let's graph x is less than or equal to -2. So we find on our number line wherever -2 is. This time we have or equal to, so it includes the point. We're going to shade this point in. And then the less than side would be the whole left side of that point. Okay, this one gets a little bit trickier. These ones are called compound because it's two inequalities in one. Whenever it says or, then we can have either one true. So we're going to find on our number line wherever our 1 is, wherever our -4 is. Put our circles there. Notice that for this one, x is less than or equal to -4, so we're going to shade in -4. The other one, x is greater than 1, it doesn't include the point. So what we're going to do from here is we're going to do this one, x is less than -4, so from -4, the less than side is to the left. We shade that side. And then on the other side, x is greater than 1. The greater than side of 1 is the right. So we shade the right hand side. Okay, this one's a little different. This was an and. So if we find our 0 and our 3, both of these are open, right? Because they're just greater than and less than. Now for these ones, whenever we have an and, we're looking for where they overlap. So where is greater than 0? Well, to the right side, right? To this side. And where is less than 3? To the left side of that. So where these are both true, which is the in between, we're going to shade between our points. Okay, and then the last one, we're going to write an inequality. So remember where we said we have the overlap, this is an and. We're going to make a note of that. We're going to make a note of this one is shaded in, this one is open. So we're going to say that x is greater than or equal to, because the bubble shaded in here, -5, and because we're doing the overlapping section right between the points, x is greater than 0. Oh, sorry, greater than. X is less than, because it's to the left hand side of 0. Okay, that's it. Kind of a lot of stuff to cover. If you haven't already touched on the set and interval notation stuff, and if you need a refresher on your compound inequalities, but very doable. Please let me know if you have any questions next class. We can go over them, and good job.